Example 7. A cable TV company is laying cable in an area with underground utilities. Two subdivisions are located on opposite sides of a creek, which is 100 meters wide. The company has to connect points P and Q with the cable, where Q is on the north bank, 1,200 meters east of P. If it costs $40 per meter to lay the cable underground and $80 per meter to lay the cable underwater, what is the least expensive way to lay the cable? Okay, so to start out, we're going to want a diagram, and then we're going to also want some variables. Okay, so we know that there's a creek, okay, and we know that our creek is 100 meters wide. So we know that this distance here is going to be 100 meters. So they tell us that point Q is on the north bank, so it's going to be up here somewhere along this top bank. And it is 1,200 meters east of P. So for Q to be east of P, P is going to be over here. Okay, and then Q is going to have to be up here, 1,200 meters east. So that means that this distance right here is going to be 1,200 meters. Okay. So to lay our cable, what we're going to do is, because it's cheaper to lay it underground, there's going to be a certain amount of cable that we lay along the shore, and then eventually at some point, which we need to figure out, we're going to cut across. Okay. So this first part here is laying the cable underground, which is cheaper, and then at some point it's going to be cost effective to cut across. Okay. And we do have to cut across because we have to get across that river somehow. Okay. So what I'm actually going to do is I'm going to form a triangle right here, and I'm going to let this distance be my variable x. Okay. And that is sort of a random thing to do, but it's going to work out nicer when we actually do our derivatives and calculations. Okay, so that means that this remaining distance here would be the 1,200 meters minus the x that I already have. So this is going to be 1,200 minus x. And then the last part here, this distance that we laid under the water, I'm going to call that r. Okay. And by the power of technology, I've actually replaced it with a nicer looking diagram there. So I've declared a let statement. R is going to be the amount of cable under the water. Okay. And C is going to be the cost of laying the cable, because that's what we're actually interested in. We're trying to find the least expensive way to lay the cable. X I could also define, it's already defined in my diagram as well. Okay, so is R, but you could write a let statement if you wanted. Okay, so we need to come up with an equation for cost. So to find an equation for cost, it's going to be the cost of the cable on ground plus the cost of the cable underwater. So to find the cost of the cable underground, we're going to take the amount of cable underground, which in this case is the 1,200 minus x, and we're going to multiply by the cost per meter, which would be $40. So cost times the amount of cable, that would give us the cost of cable underground, and then we're going to do the same thing for the cost of the cable underwater. So we're going to do the cost per meter, or the rate, and then we're going to multiply by the amount underwater, which is r. Now, just like before, we have an equation with 3 variables. We want to get it in terms of 2 variables. We can rewrite r in terms of x. Because this is a right angle triangle, we know that this side is 100 meters since it's the width of the river, or the creek, and then we've defined this to be x. So we can actually rewrite r as r squared equals x squared plus 100 squared, using Pythagorean theorem. And then if we isolate for r, we would get x squared plus 10,000. And now we only take the positive square root because, of course, r represents a length, and length must be positive. Okay, so we will ignore the negative square root. Okay, and that's because of our restriction on r. So we can now replace that r with this expression in terms of x. and we will have an equation in terms of just two variables now. And then I want you guys to pause the video and take the derivative of that. Okay, so this would be our derivative. We have a half times the 2x, so those would cancel each other out. And we can simplify this a little bit. Okay, and we can also set it equal to 0. Because of course we're trying to find the least expensive way, we are trying to minimize. So we're going to set it equal to 0. And then we are also going to move this square root to the denominator since it has a negative exponent. And the x would stay up above. So there's our derivative. We've set it equal to 0. We now need to solve this. So we're going to solve it by moving that 40 over to the other side. And then we can multiply both sides here by the denominator, so by that square root of 10,000. And the other thing that we can actually do is we can reduce both sides. So if you notice, we have a 40 and an 80. We can divide both sides by 40. And that will nicely cancel this out so that we're left with 1 equals 2x all over the square root of x squared plus 10,000. Okay. And I'm also going to multiply both sides by that denominator. So on this side I end up with x squared plus 10,000. And then on this side I just have my 2x. So that's a good start. Next, if we're trying to get x alone, we're going to want to get rid of this square root. And the way we're going to do that is we are going to square both sides of the equation. Remember, what we do to one side we have to do to the other. So if we square both sides, we end up with x squared plus 10,000 equals 4x squared. Okay. Now I'm going to isolate x. So I'm going to move all the x's to one side. Again, divide both sides by 3. And then I'm going to square root. And once again, we will ignore negative root since x has to be greater than or equal to 0. So we've successfully found the x. Now remember, the x actually isn't anything interesting in our question if we think back to this diagram. What we've really found is this, but they're asking us what is the least expensive way to lay the cable. So they're really wondering how far should they go underground and how far should they go underwater. So they're really asking us to tell them what this 1200 minus x is, and they're asking us to tell them what the r is. So we need to find out what 1200 minus x is, and we need to figure out what r is. So if we go back to the bottom here, the underground, which I can spell, is going to equal 1200 minus the square root of 10,000 over 3. And then we're also going to do the same thing for the underwater. Okay, so by plugging our x into the expression that we had for r, which was the amount of cable underwater, we get that there is 115.4701 meters of cable underwater. So then we just have to write our therefore statement, and we should always do our little verification check to make sure that this is in fact a minimum. Okay, so for the verification, we would use the x, and we are going to plug something on both sides into C prime. So I chose 57 and 58. So if we plug 57 into V prime, we get that it is decreasing. So we had a negative there. And then when you plug a 58 in, you get that it's positive, which would mean that it's increasing. So in fact, it is a minimum, and our check is fine. Okay, so the last thing here is to write out a little therefore statement. Therefore, they should lay 1,142.2650 meters of cable underground, and then 115.4701 meters of cable underwater in order to minimize the cost.